Hello there, welcome to the October 2020 paper 2. Here on the final question, question 7. So a student wants to make a plastic chess piece using a 3D printer. Figure 1 shows the central vertical cross-section of the student's design for one chess piece. The plastic chess piece is formed by rotating the region around the y-axis, the x-axis, the line with the equation x equals 1, the curve C1 and the curve C2 through 360 degrees around the y-axis. The point A has coordinates 1, 0.5 and coordinate B has coordinates 0.5, 2.5, where the units are centimeters. The curve C1, so that's between B and A here, is modelled with the equation x equals ay plus b. Determine the values of A and B according to the model. Well, given that point B is at 0.5, 2.5, and A is at 1, 0.5, we can just plug in these coordinates and work out what A and B are. So for the first coordinate, 0.5 is the x coordinate, equals A over 2.5 plus B. So if we times that to the other side, we're going to get 0.5 times 2.5, which is 1.25, plus 0.5b equals a. So that's from the first coordinate. Now from the second coordinate, it's going to be x equals 1 equals a over 0.5 plus b. So it's going to be 0.5 plus b equals a. So if these two expressions here are both equaling a, then the expressions must be equal to each other. That's not right, is it? 0.5b. So 0.5b equals 0.5 plus b. So moving things onto the same side, we'll move the 0.5b's onto the right hand side, subtract that onto the left hand side, and we get 0.7 equals 0.5. So therefore b equals 3 over 2, or 1.5. So therefore A is equal to 2. So therefore the equation is x equals 2 over 1.5 plus y, or y plus 1.5. Okay, so now moving on to part B, just a reminder that curve C1 is x equals 2 over y plus 1.5. So that's that section there, and the coordinates are, I don't know, I've forgotten what the coordinates are, 0.5, 2.5, and A is coordinate 1, 0.5. So that's 2.5 in there. Yeah, that's good. Yeah, that's right. Okay, so the coordinate C2 is modelled as an arc of a circle with centre 0, 3. So at the moment the height is 2.5, so the height here is 3, so this is coordinate 3, 0. So therefore the radius of this circle here must be the distance between the centre of the circle and 0.5, 0.25. So if I just quickly do that on the calculator, it's a Pythagoras calculation of the square root of 0.5 squared plus between 3 to 2.5 is 0.5 squared. So that is root 2 over 2. So the equation of the circle is it's just x squared plus y minus 3 squared equals 1 over root 2, so that is going to equal a half on the right hand side. Right, now we're revolving around the y-axis. What I'm going to do here is I'm going to split my diagram up into 4 pieces. I'm going to split it up into this piece here, and this piece down here. So I've got 4 sections, section 1, section 2, section 3, and section 4. So we'll do the top section first. The top section, section 1, is just half of a sphere, and a sphere has a volume of 4/3 pi r cubed. Now the radius here is root 2 over 2, so it's going to be 4/3. Actually, that's a whole sphere, so half a sphere will be divided by 2, so it's therefore going to be 2/3 pi times by 1 over root 2 cubed, which is going to be 2 pi over 6 root 2, because the root 2 will be 2 root 2 once it's cubed, times by the 3, so that'll give you 6 root 2. But then we probably want to rationalise the denominator, so it's going to be times top and bottom by root 2, but then that will cancel out 2 from the top and bottom, so it's root 2 pi over 6. Okay, so that's the that's the volume rather, of section 1. Now section 2 is going to be an integral part. So we need to integrate the circle around the y-axis between the y-coordinates of 3 and 2.5. So it's going to be pi times the integral from 3 from 2.5 of x squared. Now x squared is going to be a half minus y minus 3 squared. So that's going to be y squared plus 6y once you take into account the double negative, and then minus 9 dy. So that's what x squared is equal to. Let's simplify this. It'll be minus 9 plus a half, so that's going to be minus 8 and a half. 9 minus half is 17 over 2, so it'll be minus 17 over 2. So the integral is pi times the integral from 3 to 2.5 of minus y squared plus 6y minus 17 over 2 dy. Let's now integrate it, so it's going to be equal to pi times minus a third y cubed plus 3y squared minus 17 over 2y between the boundary of 3 to 2.5. So if we now plug both of those values in and just plug it into the whole expression, and we'll get some values there. So when we plug it in, we're going to get in total 5 over 24. So when you plug 3 in and work each of them out, when you plug 2.5 in, work each of them out, and then do one subtract the other, you get 5 pi by 24 for that area there. Okay, so that's section 1 and section 2 covered now. So now we need section 3 and section 4. Okay, let's move on to the third and the fourth parts, just giving myself a bit more space here. So now the next part is going to be done by integration as well. So this is going to be done by the integral between the y boundaries of 0.5 up to 2.5. And then it's going to be x squared again. Oh, don't forget to times by pi on this. So it's going to be 2 over 1.5 plus y squared dy. Now let's just rewrite this slightly. Let's expand the brackets, and maybe there'll be a 4 on the top. So let's factorise that 4 to the front. Integral between 2.5 to 0.5. Remember, your boundaries are the y values, so 2.5 to 0.5. And then it's going to be 1.5 plus y to the power of minus 2. It's still going to be squared, and now it's minus because it was on the bottom of a fraction, dy. Now you can do this by integration by substitution, or maybe you can just do it by integration by observation. The integral is going to be increase the power by 1, divide by the new power, so it now be minus, and given that there's no differential from the middle of the bracket there, nothing has to divide to the front. So that's going to be in between the boundaries of 2.5 to 0.5, and if you plug those in, taking it nice and steady, what you get is when you plug in fact, let's just do it. It's going to be minus 1 over 1.5 plus y between the boundaries of 2.5 to 0.5. The first value substituted in will be 4 pi, and then 1.5 plus 2.5 will be 1 over 4, so minus 1 over 4. And then it'll be minus 0.5 substituted in, so that'll be 1 over 2, so it'll be minus 1 over 2. So then when you sort out the middle of this bracket here, the middle of the square bracket, you're going to get a quarter for the double negative on the half, minus a quarter is a quarter, times by the 4, and you actually end up just with pi. So on this third section here, the area here for area volume 3 is just equal to pi. Now the last final bit is just going to be a cylinder, because if you imagine what's happened here, it's just a cylinder that's been rotated round. It's going to have a radius of 1 and a height of 0.5. So a cylinder for section 4. We may even want to label our sections here. Label area volume 2, volume 3, volume 4 is going to be a cylinder, so pi r squared h. So it's going to be equal pi times by 1 squared times the height of the cylinder, which will be 0.5. So it's just a half pi. Right, so we've now got all 4 of these volumes. Volume 4 is equal to pi by 2. So therefore, the total volume of this chess piece is going to be determined by calculus the volume of the plastic. Yep, okay, so that's the answer. So it's going to be root 2 pi over 6 plus 5 pi by 24 plus just a bog standard pi plus a pi by 2. And if we simplify the last 3 things, we can group all of those bits together. So just type that into the calculator and you're going to get 41 pi over 24. I suppose if we're looking to simplify this in the simplest way possible, maybe we might create a common fraction between the 2 terms, so it would now be 4 root 2 over 24 pi, and then we could factorize out the pi and the 24 to make it 41 plus 4 root 2. And there we are, so that is going to be in units cubed. Did it say the units here? Centimetres. Centimetres cubed. So there we are, that's the answer for this question here. So there we are, and that's the answer for question 7 in total, worth 11 marks for that question. And that's the whole of October 2020 Core 2 paper. Core Paper 2. So there we are. Hopefully you found that set of solutions there quite helpful. Good luck with June 2021, and maybe you're working in advance and maybe you'll now see the solutions for June 2021. So feel free to move on and watch those. Thanks very much for watching.